All right, class, so this is our GC data. So I'm going to run you through how to interpret this really quickly, and then also how to calculate the actual areas based off of the printout that you get when you print out your information. So this is the chromatogram. This is what the raw data sort of looks like. And we've got our different peaks for our different solvents that have come through. This giant peak on the left, that's the first thing that's coming through. We can see that retention time is about 1.9 minutes. That's our dichloromethane solvent. So we're going to basically just ignore that whole giant peak. Then I've got two little solvents, little peaks coming out here. One at 2.135 minutes and one at 3.650 minutes. And those are going to be the things that we need to identify. So what I'm going to do is I'm going to go to my table from the slides that give you the retention times. Now these retention times, they might not be exactly the same, but they're going to be pretty close. So if we take this 2.135, that's pretty clearly hexane. So we're off by 0.07 there, but I think it's safe to say that that's going to be our hexane. And then at 3.65, well, that's pretty clearly going to be toluene, so 3.69. So this identifies our two peaks. So we know that this one's hexane and we know that this one's toluene because those retention times match up. Now, the next thing we're going to do is we're going to look at our actual data. So here's our actual data printout. And I'm going to look for those times. So here I see the retention time, 2.135 minutes. And then this area counts, that's going to be the area of that peak. Same thing for toluene. I've got my peak here and then my area there. So the last thing we need to do is we need to sort of take into account the response factor. So for hexane, for instance, the way that we're going to calculate that, we're going to take our area counts, and we're going to divide that by the response factor. That's going to give me my actual area, and that's what we're going to use to sort of figure out the percentages of hexane to toluene in your sample. So for me, in this case, that's going to be 409955 divided by the RF for hexane, which is 1.180. And I'm just using that again from our slideshow. We've got our response factors. So for hexane, 1.18, for toluene, 1.332. So the area counts, that's from our data, divided by the response factor. That gives me my actual area. So let's just do this real quick. So this is going to be the actual area of my hexane. I can do the same thing for toluene. And that's going to be 98315. So just reading that number, it's probably hard to see, but that's my area that I have here from my data. And divide that by 1.332. So these are now my areas for my hexane and toluene. And so if I add these together, that's going to give me my total area, right? So then if I want to find my percentage of hexane, I'll take this value divided by the total value. That gives me my percentage of hexane. And then, you know, the same thing for toluene. So these two percentages should add up to 100. We're going to ignore the dichloromethane peak, right? So we've got a huge area for our dichloromethane, but that's just our solvent. We don't really care about that. We're just going to ignore that. All right, hope that helps.